Imagine standing still for a moment, holding something ordinary in your hand, a small stone, a coin, something you have dropped so many times that it no longer feels like an event. Now let it go. It falls. The motion feels inevitable, as if falling were a built-in instruction written into the object itself. But that certainty is an illusion. Nowhere in the universe is there a rule that says down must exist. What you are feeling is not gravity pulling on the object, but the result of standing on a massive planet that quietly curves the space around you. For centuries, Newton gave us a rule that worked. Every mass attracts every other mass. With it, we could explain falling apples and orbiting moons. But the rule never explained what gravity truly is, or why in a falling elevator, weight seems to disappear. Falling feels like the most obvious motion in the world. From the moment you can stand, you learn it without being taught. You release something from your hand and it moves away from you, downward toward the ground. The pattern repeats so perfectly that it becomes invisible. You stop noticing it. Falling stops being an event and turns into an expectation. Over time, that expectation hardens into intuition. It feels as if objects fall because that is simply what objects do, as if matter carries a quiet instruction telling it which way to go. But that intuition is shaped entirely by where you live. On the surface of Earth, down feels absolute. The ground is always beneath you. The sky is always above. Every movement seems to agree on the same direction. Yet this agreement is not a universal rule. It is a local habit. Far from planets, far from stars, far from anything massive enough to shape motion, there is no preferred direction at all. No up, no down. No natural tendency to fall. Objects released in deep space do not rush toward anything. They simply continue, unchanged, along whatever path they were already moving. The sensation of falling is not something the object experiences. It is something you infer by watching motion relative to yourself. And you, without realizing it, are standing on a curved surface of space-time. Gravity does not announce itself as a force you can feel directly. What you feel is resistance, the pressure of the ground against your feet, the chair pushing against your body. Remove that support and the sensation disappears, even though gravity itself remains. This is the first illusion gravity creates, that falling is natural and stillness is neutral. In reality, it is the opposite. What feels like rest is often a state of constant resistance, and what feels like falling is simply motion, uninterrupted. Understanding gravity begins by letting go of the idea that down is real, and realizing it is something Earth quietly teaches you every day. Once the idea of down begins to loosen, gravity starts to feel less like a command and more like a condition. On Earth, every movement seems to agree on the same direction. Rain falls, smoke rises, rivers carve their way towards the sea. This consistency makes gravity feel universal, as if the entire cosmos shares the same orientation. But that agreement exists only here. If you are carried far from Earth, beyond the reach of its mass, the idea of direction would slowly dissolve. Release an object, and it would not fall. It would not rise. It would simply remain with you, drifting, indifferent to orientation. Motion would no longer favor any path. In deep space, stillness is not an absence of motion. It is motion without interference. Objects continue exactly as they were, not because they are held in place, but because nothing bends their path. Gravity is the reason paths bend. Near a massive body, straight lines are no longer truly straight. Motion that would otherwise continue forever is gently redirected. To someone standing on a planet, that redirection looks like falling. To the object itself, nothing special is happening at all. This is why gravity is so difficult to recognize for what it is. It does not feel like being pulled. It feels like losing support. The moment the ground is removed, the sensation vanishes, even though the underlying cause remains unchanged. What we call weight is not gravity acting on us. It is the constant upward push of the surface beneath us, resisting a motion we would otherwise naturally follow. Gravity's second illusion is subtle but powerful. It convinces us that rest is natural and motion requires a cause. In truth, it is motion that is natural. What we call rest is simply motion held back. Once this illusion cracks, gravity begins to look less like a force and more like a quiet distortion shaping every path we take. For a long time, the language we used to describe gravity made it feel familiar. We spoke of attraction, of pulling, of forces reaching across space to guide the motion of objects. This language was powerful because it worked. With it, we could calculate trajectories, predict impacts, and trace the movements of worlds with remarkable accuracy. Isaac Newton gave gravity a simple rule: every mass attracts every other mass. The more mass something has, the stronger the attraction. The farther apart two objects are, the weaker it becomes. With this idea, the universe became predictable. The same rule explained why an apple falls and why the moon does not. It falls too, but sideways, forever missing the Earth as it curves around it. Planets followed paths that could be written in equations and checked against the sky. Newton's gravity was not just successful, it was precise. It allowed clocks to be set, calendars to be planned, and oceans to be crossed. For centuries, nothing contradicted it. And yet, beneath its success, something remained unspoken. Newton's law described what gravity does, but not what gravity is. It offered no picture of how one object reaches out to another across empty space. There were no threads connecting them, no medium carrying the influence. The attraction simply existed. Even Newton himself was uneasy about this silence. Action at a distance without a mechanism felt incomplete. But the predictions were correct, and so the question was set aside. As long as gravity behaved as expected, the absence of an explanation did not feel urgent. The universe obeyed the rule. The reason why could wait. That unasked question would linger quietly, waiting for a situation where the old language would no longer be enough. The unanswered question did not disappear. It simply stayed quiet. For generations, gravity behaved itself. Planets moved where they were supposed to. Predictions matched observations. The universe followed the equations closely enough that the lack of a deeper explanation felt almost irrelevant. As long as nothing strange happened, the silence could be ignored. But physics has a way of exposing its gaps when conditions change. Light, for example, never behaved the way gravity did in Newton's picture. Light did not leap across space instantaneously. It traveled. It had a speed, a finite, measurable limit. Information carried by light took time to arrive. Gravity, in contrast, seemed different. If the sun were to suddenly vanish, Newton's equations implied that Earth would instantly lose its orbit, responding at once to the change. No delay, no signal in transit. The influence appeared to act everywhere at the same time. This idea worked mathematically, but it clashed with a growing realization. Nothing in the universe should be able to act faster than light. The tension was subtle, but it mattered. At the same time, careful measurements were revealing something else. Gravity treated all objects the same way. Heavy or light, dense or fragile, everything fell at the same rate when air resistance was removed. This was not true for other forces. Electricity and magnetism behaved very differently depending on charge and composition. Gravity was strangely impartial. That impartiality hinted that gravity might not be acting on objects in the usual way. It was not responding to what something was made of. It was responding only to the fact that it existed. The deeper physicists looked, the more gravity refused to behave like a conventional force. Then comes a simple thought experiment. Not a complicated machine, not an extreme condition, just an ordinary situation imagined carefully. Picture yourself inside a small, sealed elevator. The walls are solid. There are no windows, no way to see outside. The space is quiet and enclosed. At first, everything feels normal. Your feet press against the floor. Objects rest where you place them. Gravity feels present and familiar. Now imagine the cables snap. The elevator begins to fall. Instantly, the sensations you associate with gravity change. The pressure beneath your feet disappears. Your body no longer presses against the floor. Objects released from your hands do not drop. They drift, hovering beside you. Inside the elevator, gravity seems to be gone. But nothing fundamental has changed. The Earth has not vanished. Its mass is the same. The distance between you and the planet is almost unchanged. According to Newton's law, gravity should still be acting just as strongly as before. And yet, you feel weightless. This is not a trick. It is not an illusion caused by motion. It is a real physical state. Astronauts experience the same thing while orbiting Earth. They are not beyond gravity's reach. They are falling continuously, missing the planet as it curves away beneath them. What matters is not the presence of gravity, but the presence of support. When you stand on the ground, gravity is trying to guide you along a path. The ground prevents that motion by pushing back. That push is what you feel as weight. Remove the ground, remove the push, and the sensation disappears. This realization is deeply unsettling. It suggests that gravity does not act like other forces at all. You cannot feel it directly. You can only feel resistance to it. In the one situation where gravity is allowed to act freely, it becomes invisible. This is the moment where the old language begins to fail. If gravity were truly a force like any other, you would feel it most strongly when it acts without interference. Instead, you feel nothing. The absence of sensation becomes the clue. From this quiet contradiction, a new idea begins to form, an idea that will not describe gravity as something that pulls objects through space, but as something that reshapes the space they move through. The falling elevator does not remove gravity. It reveals what gravity really is. From that realization, Einstein took a step that feels almost backward. Instead of asking how gravity pulls objects, he asked what objects do when nothing interferes with them. What motion looks like when it is left completely alone. The answer is simple. An object moves along the straightest possible path it can follow. This idea is older than gravity itself. It comes from inertia. Motion does not need a cause. Only changes in motion do. Left undisturbed, an object simply continues. The falling elevator reveals something crucial. Inside it, you are not being pulled downward. You are moving freely, following your natural path. Nothing is forcing you away from it. Gravity, whatever it is, has become invisible because nothing is resisting it. If this is true, then standing on the ground is the unusual situation. When you stand on Earth, your natural motion is being interrupted. The surface beneath your feet prevents you from following the path you would otherwise take. The ground pushes upward, constantly accelerating you away from free motion. That upward push is what you feel as weight. In other words, gravity is not what presses you into the floor. The floor presses into you. This reversal is subtle, but profound. It means gravity does not behave like a force acting within space. It behaves like a feature of space itself. Einstein realized that space and time cannot be separated. They form a single structure woven together. Motion through space affects motion through time. Speed changes how clocks tick. Acceleration changes how events line up. And mass does something even stranger. Mass changes the shape of this structure. Instead of pulling objects toward it, mass bends the geometry of space-time around it. Paths that would be straight become curved. Motion that would continue unchanged is gently redirected. An object near a massive body is not being pulled off its path. Its path has changed. This is why gravity treats all objects the same way. A feather and a hammer fall together in a vacuum, not because gravity pulls equally on them, but because space-time offers them the same path to follow. Their mass does not matter. Their composition does not matter. Only the shape of space-time does. This also explains why gravity disappears in free fall. When you are falling, you are simply following the geometry as it is. No force is required. No sensation is produced. The sensation only appears when something blocks that motion. Time itself is part of this geometry. Near a massive object, time flows more slowly. This is not a mechanical effect. It is not caused by clocks malfunctioning. It is built into the structure of space-time. A clock on the ground ticks more slowly than a clock higher above Earth. The difference is tiny, but real. It has been measured countless times. It must be accounted for every day. Satellites orbiting Earth experience weaker gravity and move at high speeds. Both effects change how time passes for them. Engineers must correct for these differences, or modern navigation systems would fail within hours. Gravity, then, is not only about falling. It shapes motion. It shapes paths. It shapes time itself. What began as a simple observation that objects fall has led to a picture of reality where space and time are dynamic, responsive, and quietly curved by the presence of mass. The apple does not fall because the Earth pulls on it. It falls because space-time beneath it is curved, and the apple is simply following the straightest path it is allowed to take. And the ground rising up to meet it is what brings the fall to an end. Once gravity is understood as geometry, familiar scenes begin to look unfamiliar. Orbits are no longer the result of a constant pull. A planet circling a star is not being tugged inward every moment. It is moving freely, tracing a path through curved space-time. The curve is gentle and continuous, and so the motion never ends. This is why an orbit feels stable. Nothing is fighting against gravity. Nothing needs to be corrected. The planet is simply following the shape of the space it inhabits. Light follows these paths as well. Although light has no mass, it still travels through space-time. When space-time curves, light curves with it. This is not because light is being pulled, but because the geometry it moves through is no longer flat. A beam of light passing near a massive object bends slightly from its original direction. The effect is tiny, but measurable. During solar eclipses, stars appear shifted from their usual positions because their light has curved around the sun on its way to Earth. This bending allows the universe to act like a lens. Entire galaxies can magnify and distort the light of more distant galaxies behind them. Rings and arcs appear in space not because anything is being stretched or smeared, but because space-time itself is guiding light along curved routes. In these moments, gravity reveals itself visually, but its influence goes deeper than motion and light. It reaches into time. Near a massive object, time flows more slowly. This slowing is not a side effect. It is central to how gravity works. Space and time curve together. You cannot change one without affecting the other. If you place two identical clocks at different heights above Earth, they will slowly drift out of sync. The clock closer to the ground will tick more slowly. The difference is small, but relentless. Time near mass passes more slowly because space-time is more curved there. This is not theoretical. It is part of daily life. Satellites orbiting Earth must constantly adjust for this effect. Without corrections for gravitational time dilation, navigation systems would fail. Distances would blur. Locations would drift. Gravity is shaping time quietly, continuously, everywhere. On even larger scales, the same rules apply. Stars orbit the centers of galaxies along paths carved by immense concentrations of mass. Gas clouds collapse where space-time funnels matter inward. Structure forms because geometry allows it. And in the most extreme cases, the curvature becomes overwhelming. When enough mass is packed into a small enough region, space-time bends so sharply that paths lead inward and do not return. Light cannot escape. Time slows without limit. An event horizon forms. A black hole is not an object in the usual sense. It is a region where geometry dominates completely, where the shape of space-time itself determines what can exist and what cannot. Yet even here, gravity is not a force pulling outward or inward. It is geometry, carried to an extreme. All of this begins with something deceptively simple, an object released from your hand, falling toward the ground. What feels like the most ordinary motion is actually the visible trace of a curved universe, a universe where space is flexible, time is uneven, and motion follows shapes too subtle to see directly. Gravity does not shout its presence. It whispers it. Through the paths, everything takes. Even with this geometric picture, gravity remains unfinished. Einstein's description is elegant and powerful, but it is not complete. It explains planets, stars, galaxies, and black holes with extraordinary accuracy. Yet when gravity is pushed into the smallest scales, into the realm of atoms and particles, the equations begin to break. At those scales, the universe behaves according to different rules. Quantum physics governs uncertainty, probability, and discrete interactions. Space and time no longer feel smooth. They jitter, they fluctuate. And when gravity enters this domain, the mathematics refuses to cooperate. The curved space-time that works so well on cosmic scales becomes unstable when examined too closely. The geometry seems to tear itself apart. Predictions lose meaning. Infinity appears where no physical quantity should. This tension reveals something important. Gravity may not be fundamental in the way we once imagined. It might not be a basic ingredient of reality at all. It could be an emergent effect, a large-scale consequence of deeper, microscopic processes we do not yet fully understand. There are hints of this idea scattered throughout modern physics. In certain theories, space-time behaves like a fluid. In others, it resembles a network of information. Some approaches suggest that gravity arises from entropy, from the tendency of systems to move toward disorder. In these views, falling is not caused by attraction, but by statistics. None of these ideas are confirmed, but all of them point in the same direction. Gravity is quieter and more subtle than we expect. Even gravitational waves, once thought impossible, fit into this picture. When massive objects accelerate violently, colliding black holes, merging neutron stars, ripples spread through space-time itself. Not waves moving through space, but waves of space. These ripples pass through Earth constantly. They stretch and compress distances by amounts smaller than an atom. For most of history, we had no way to notice them. Only recently did our instruments become sensitive enough to listen. When we did, the universe revealed a new voice. Gravity can vibrate. This discovery did not change our daily experience. Objects still fall, planets still orbit. But it confirmed that space-time is not rigid. It is dynamic, responsive, alive with motion, and yet, despite everything we've learned, gravity remains the least understood interaction in nature. We cannot isolate it in a laboratory. We cannot shield against it. We cannot explain why it exists at all. It shapes the universe on the largest scales, but slips through our fingers on the smallest ones. Perhaps this is why gravity feels so familiar and so strange at the same time. It is the first force you ever experience, and the last one physics has fully explained. Every step you take, every object you release, every moment you remain standing still is part of an ongoing interaction with the geometry of the universe. You are not being pulled downward. You are moving through a curved reality, guided silently by a structure you cannot see, but cannot escape. Gravity is not something that happens to you. It is something you are already inside. Seen this way, gravity is no longer an event that happens occasionally. It is a background condition, always present, always shaping the paths you take. Even when nothing seems to be moving, when you stand still, you are not motionless in any absolute sense. You are being held in place by the surface beneath you, prevented from following the path space-time lays out. Every second you remain standing, the ground is pushing you away from free motion. That push is small, constant, so familiar that it disappears into sensation. Remove the ground and nothing dramatic happens. No sudden pull, no rushing force, just quiet motion continuing on its way. Falling feels violent only because we are accustomed to resistance. This is why gravity is so easy to misunderstand. It does its work best when it is not felt at all. The universe is filled with objects in free fall. Planets, moons, stars, entire galaxies. They move not because something is constantly forcing them, but because the geometry they inhabit guides them gently along curved routes. Even you are part of this motion. The Earth is falling around the sun. The sun is falling around the center of the galaxy. The galaxy is falling through the large-scale structure of the cosmos. There is no final point of rest, only layers of motion nested inside one another. Gravity does not demand energy to sustain this motion. It does not drain fuel. Once the geometry is set, motion continues naturally. This is why the universe can remain stable for billions of years without correction. And yet, this stability is fragile. Change the distribution of mass, and space-time reshapes itself. Paths adjust, orbits shift, light bends differently, time flows at new rates. Gravity responds not with force, but with geometry. This responsiveness is what allows the universe to evolve. Stars are born where space-time funnels matter inward. Galaxies form where vast structures guide motion on unimaginable scales. Even the expansion of the universe itself is shaped by gravity's influence on space-time. In the early universe, gravity amplified tiny irregularities, turning small differences into structure. Without it, matter would have remained spread thin and featureless. No stars, no planets, no surfaces to stand on. Gravity made complexity possible, and yet it remains invisible. You cannot point to it. You cannot bottle it. You cannot escape it. It does not reside in objects alone, but in the relationships between them, in the way mass and energy shape the stage on which everything else unfolds. This is why gravity feels so different from other interactions. It is not something added to the universe. It is woven into its fabric. To understand gravity is not to learn a new force, but to unlearn an old assumption that space is empty, passive, and unchanged by what moves within it. Space is active, time is flexible, motion follows curves you cannot see. The next time something slips from your hand and falls, nothing special has occurred, no command was issued, no pull was applied. A path was followed, a curve was traced. A quiet rule of geometry revealed itself for an instant, and then, just as quickly, it disappeared again, hidden beneath the feeling of standing still. There is a final subtlety that gravity introduces, one that is easy to miss because it unfolds so slowly. Gravity does not merely guide motion through space. It organizes the flow of the universe over time. Because space-time is curved, events do not unfold at the same rate everywhere. Two observers following different paths through gravity will not agree on how much time has passed, even if they begin and end together. Their clocks will tell different stories. This is not a limitation of measurement. It is not an error. It is the nature of time itself. Near a massive object, time moves more slowly. Farther away, it speeds up. The difference is tiny near Earth, but it never stops accumulating. Second by second, gravity quietly separates moments. This means the universe does not share a single universal now. Each path through space-time carries its own rhythm. Each location experiences its own version of time. Gravity, then, is not just shaping where things go. It shapes when things happen. In regions where space-time is deeply curved, time stretches so dramatically that it nearly freezes from an outside perspective. Near a black hole, an object appears to slow, dim, and linger at the edge, never quite crossing. From its own point of view, nothing unusual occurs. Time flows normally along its path. Two realities coexist, both correct. This is gravity's quiet power. It allows multiple truths to exist without contradiction. And yet, despite its reach, gravity remains astonishingly gentle. Compared to other forces, it is extraordinarily weak. A small magnet can lift a paperclip against the pull of the entire Earth. On human scales, gravity seems almost fragile. Its strength lies not in intensity, but in universality. Gravity affects everything with mass and energy without exception. It cannot be screened, canceled, or avoided. Even light, massless as it is, must obey the geometry gravity creates. Because of this, gravity becomes dominant over vast distances. Where other forces fade or neutralize, gravity accumulates. Over millions of years and trillions of kilometers, its influence shapes galaxies and clusters, weaving structure from emptiness. This is why gravity defines the large-scale universe. and why it defines your smallest experiences as well. Every breath you take, every step you make, every moment you remain standing instead of falling freely, you are constantly negotiating with space-time. The ground beneath you is not passive. It is pushing upward, interrupting a motion you would otherwise follow. Your body is slightly compressed by this resistance. Bones, muscles, and cells all respond to a condition so ordinary that it fades from awareness. Gravity is not pulling you down. You are being held up. And when that support disappears, even briefly, gravity does not announce itself. There is no surge, no tug, no warning. There is only silence and motion continuing as it always has. This is perhaps the most unsettling realization of all. Gravity is not dramatic. It is not violent. It does not demand attention. It shapes reality while pretending not to exist. It teaches you to believe in down, in stillness, in rest, all while quietly revealing that motion is the default and resistance is the exception. To understand gravity is not to master a force. It is to recognize a condition you have never left. You have been in free fall since the moment you were born. The earth has simply been in your way. At this point, gravity stops feeling like a topic and starts feeling like an environment, something you are immersed in, rather than something acting on you. Once you see it this way, many everyday ideas quietly collapse. There is no true stillness. There is no absolute rest. What feels like stability is simply a balance between motion and resistance, maintained moment by moment. Even the solid ground beneath you is not stable in any fundamental sense. It is a structure of atoms held in place by forces far stronger than gravity, constantly resisting a motion they would otherwise follow. The planet feels rigid only because those forces are relentless. Remove them, and everything falls, not downward, but along paths shaped by space-time itself. This perspective also changes how distance works. In a curved universe, distance is not just about how far apart 2 points appear. It is about how space-time connects them. The shortest path may not look straight. The fastest route may not feel direct. Light reveals this quietly. It always takes the shortest possible path through space-time, even when that path curves. To us, the bending looks like distortion. To light, it is simply geometry. Gravity does not slow light by pulling on it. It changes the meaning of straightness. And because time is woven into that geometry, gravity also changes how long journeys take, not just through space, but through existence itself. Two identical particles can follow different paths and age differently. Two clocks can tick at different rates simply because one spends more time deeper in a gravitational field. These are not edge cases. They are the natural consequences of living in a curved universe. The universe does not provide a single timeline. It provides countless overlapping ones. Gravity keeps them from drifting apart completely. On cosmic scales, this coordination is what allows structure to exist. Without gravity, matter would drift endlessly. No stars would ignite. No planets would gather. No chemistry complex enough for life would persist. Gravity slows the universe down just enough for things to happen. Yet it never truly stops anything. Stars burn out, orbits decay, galaxies collide. Over immense time scales, gravity continues to reshape everything patiently, without urgency. Even black holes are not endpoints. They grow, they merge, they evaporate, eventually through processes so slow they challenge the meaning of duration itself. Gravity is not static, it evolves. And through all of this, It remains indifferent. It does not favor complexity or simplicity. It does not aim for beauty or order. It responds only to mass, energy, and motion, shaping space-time accordingly. That indifference is what makes it reliable. It is also what makes it difficult to grasp. We are drawn to forces that announce themselves: impacts, explosions, sudden changes. Gravity offers none of these. Its most profound effects unfold quietly, over time spans too large to feel. And yet, it is the reason you are here at all. Every atom in your body was assembled in environments gravity made possible. Every chemical bond formed under conditions gravity sustained. Every moment of awareness you experience occurs because gravity allowed matter to organize instead of disperse. You do not notice gravity because it has never left you. It has shaped your intuition from the beginning, teaching you what feels normal, what feels possible, and what feels impossible. Letting go of an object and watching it fall feels trivial, but it is a glimpse into the structure of reality, a brief alignment between motion and geometry, a small, everyday trace of a universe that is constantly curving beneath your feet. Gravity does not demand that you understand it. It simply invites you to notice that you have been moving through it all along. There is a strange comfort in realizing that gravity is always there, not as a threat, not as a force waiting to act, but as a quiet structure holding the universe together. Once you accept this, the fear often associated with gravity begins to soften. Falling no longer feels like a failure of support. It becomes a return to a more natural state. Motion without resistance, paths followed without interruption. What we call stability is actually the exception. Cities stand because materials resist gravity. Mountains exist because rock resists collapse. Your body holds its shape because countless microscopic forces work constantly against a gentle geometric invitation to move. Gravity is patient. It does not rush. It waits for resistance to weaken. Over time, mountains erode, buildings crumble, stars exhaust their fuel, orbits slowly change. Nothing escapes gravity by force. Things only delay it through structure. This patience is why gravity shapes the universe so deeply. It never demands immediate results. It accumulates influence slowly, steadily, across enormous spans of time. While other forces flare and cancel, gravity persists. It does not care about scale. It acts on dust and galaxies with the same quiet rule. A single grain of sand feels insignificant. Yet given enough time, gravity can guide it into dunes, into rock, into planets. The universe does not hurry. It allows gravity to do its work at its own pace. This also means the universe is never finished. Every structure gravity creates is temporary. Stars form, burn, and fade. Galaxies collide and reshape. Even space-time itself evolves as mass and energy shift across it. There is no final arrangement, only ongoing adjustment. This is why gravity feels timeless. It is not tied to events. It is tied to relationships. Wherever mass and energy exist, gravity quietly reshapes the context around them. Even emptiness is not exempt. Regions of space that appear empty still participate in gravity. They curve, stretch, and respond to the mass around them. The voids between galaxies are not inert gaps. They are part of the same geometric fabric, subtly influenced by distant structures. Nothing is truly isolated. This interconnectedness is gravity's deepest message. No object exists on its own. No motion is completely independent. Every path is influenced by the presence of others, even across vast distances. Yet this influence does not feel intrusive. It does not interfere. It simply shapes possibility. Gravity does not force objects to collide. It defines the space in which collisions become possible. It does not command motion. It sets the stage on which motion unfolds. Understanding gravity, then, is not about predicting falls or calculating orbits. It is about recognizing the quiet architecture beneath experience, the invisible curvature guiding everything from drifting photons to turning galaxies. When you release an object and watch it fall, you are not witnessing an isolated event. You are seeing a local expression of a universal structure, a brief, familiar gesture performed by space-time itself. And when it ends, when the object meets the ground, nothing has gone wrong. A path has simply been interrupted. Geometry has been resisted. Gravity continues, unchanged. It always will. At some point, gravity stops feeling like something you can explain and starts feeling like something you live inside. It becomes less about equations and more about orientation, about why the universe feels stable enough to trust, yet dynamic enough to change. You wake up each morning expecting the floor to be where it was yesterday. You expect objects to stay where you leave them. You expect the sky to remain overhead. These expectations feel reasonable, even obvious. But they are not guaranteed by the universe. They are negotiated moment by moment through gravity. Every structure you rely on is constantly resisting motion. Floors push upward, walls push sideways, bones push inward. Without that resistance, everything would quietly begin to follow different paths. Gravity is not waiting to act. It is already acting. The question is only whether something is in the way. This is why gravity rarely surprises us. It is consistent, predictable, almost boring. Its rules do not change from one day to the next. They do not depend on intention or awareness. They operate whether you are watching or not. And yet, this reliability hides its strangeness. Gravity does not care about meaning. It does not distinguish between living and non-living. It treats mountains, oceans, cities, and bodies with the same indifference. It shapes them all. This indifference is what allows complexity to emerge without design. No plan is required. No goal is imposed. Given enough time, gravity will gather matter, concentrate energy, and create conditions where new behaviors become possible. Stars ignite not because the universe intends them to, but because gravity allows density to increase until fusion becomes unavoidable. Planets form not because they are needed, but because gravity makes accumulation more likely than dispersion. Life itself depends on this quiet bias, not a pull, not a push, a tendency for matter to follow curves rather than escape them. And once you recognize this tendency, you begin to see it everywhere. In the way water finds the lowest available path, in the way dust settles, in the way atmospheres cling to planets and slowly leak away when gravity weakens. Nothing is permanent, but nothing is random either. Gravity sits between chaos and order, shaping outcomes without directing them. Even the future of the universe is written partly in gravity's language. Whether expansion continues forever or slows, whether galaxies drift apart or collapse inward, depends on how gravity balances against other influences on cosmic scales. We do not yet know how that story ends. What we do know is that gravity will be involved to the last moment, not as a final force, but as a continuous condition. It will curve space-time until there is no more space-time to curve. It will guide motion until there is no motion left to guide. And through all of this, it will remain silent. You will not feel gravity changing. You will not hear it approaching. You will not notice it doing its work. You will simply live inside the result. Every time you stand still, gravity is being resisted. Every time you fall, gravity is being revealed. Every time you orbit a planet, a star, a galaxy, gravity is being obeyed. Understanding this does not change how objects fall. It changes how you see stillness. Stillness is not the absence of motion. It is motion held back. And gravity is the reason there is something to hold back against at all. The universe does not rest. It curves, and you, quietly, move with it. When you follow this idea far enough, gravity begins to erase the boundary between motion and existence. It is no longer clear where movement ends and where being begins. Everything that exists is already in motion, not because it is traveling through space, but because it is embedded in a geometry that never truly stands still. Spacetime is not a rigid stage. It responds. It adjusts. It carries memory of what has passed through it. Every mass leaves an imprint. Every motion leaves a trace. Gravity is the record of those traces interacting. This is why the universe has a history. Not just a sequence of events, but a shape that evolves. The distribution of matter today is not arbitrary. It reflects countless earlier motions, all guided by curvature, all layered on top of one another. The past is written into space-time itself. When galaxies collide, their paths are not random. They follow curves established long before either galaxy formed. When stars orbit galactic centers, they are responding to a geometry shaped by invisible mass, accumulated over billions of years. Even empty regions remember what once passed nearby. Space-time relaxes slowly. It does not snap back to flatness. Gravity fades with distance, but it never truly disappears. This lingering influence is what gives the universe continuity. Without gravity, every moment would be disconnected from the next. Motion would not accumulate. Structure would not persist. History would dissolve into isolated instants. Gravity stitches time together. It ensures that what happens now is constrained by what happened before. It turns existence into a process rather than a series of unrelated frames. This is why gravity feels inevitable, not because it forces outcomes, but because it preserves context. You are not just here. You are here because of everything that came before. The planet beneath you formed from dust drawn together by gravity. The star above you ignited because gravity raised pressure and temperature until fusion began. The atoms in your body were forged in environments gravity made dense enough to transform matter itself. Your presence is a consequence of curved space-time, repeated endlessly, patiently, across time. And still, gravity remains impartial. It does not preserve what exists. It does not protect what forms. It allows creation and destruction with equal indifference. Stars collapse, orbits decay, structures unravel. Gravity makes complexity possible, but it does not guarantee permanence. Everything it builds, it will eventually reshape. This is not cruelty. It is consistency. In a universe governed by gravity, nothing is exempt from change. Stability is always temporary. Balance is always conditional. Even the most enduring structures owe their longevity to circumstances, not to privilege. This realization can feel unsettling, but it can also feel grounding. If nothing is permanent, then motion is not a failure. Change is not a breakdown. Falling is not an error. They are all expressions of the same geometry, playing out across different scales and times. Gravity does not judge outcomes. It allows them. It defines what is possible, then steps back and lets events unfold. Understanding gravity this way removes the drama from it. There is no battle between forces, no struggle against nature, only paths being followed until they intersect with resistance and then redirected again. You are not fighting gravity when you stand. You are negotiating with it. And every moment you exist, that negotiation continues quietly, invisibly beneath awareness. Gravity does not ask for attention. It does not require belief. It does not announce its presence. It simply ensures that the universe remains connected to itself. That motion has meaning. That time has continuity. That existence is not scattered, but shaped. You do not need to look up at the stars to see gravity at work. You are already inside its deepest expression. At the deepest level, gravity also rewrites what we mean by distance. Two objects may appear far apart, separated by vast emptiness. Yet gravity treats that separation as negotiable. Distance is not just a measure of space. It is a measure of how space-time bends between points. What looks like a straight line is only straight, because space-time allows it. This is why light itself curves. A beam of light passing near a massive object does not slow down or hesitate. It follows the rules perfectly, but the rules themselves have changed. The geometry it travels through is bent, and so its path bends with it. To an outside observer, it looks like gravity reaching out and pulling light aside. In reality, nothing is pulling at all. Light is simply obeying the shape of the universe. This bending reveals something subtle and unsettling. Gravity does not discriminate between mass and energy. Anything that carries energy contributes to curvature. Even light, which has no rest mass, participates in shaping space-time. The universe responds to everything. This means gravity is not just a property of heavy things. It is a property of existence itself. Wherever there is energy, there is curvature. Wherever there is curvature, there is gravity. Even you, sitting still, contribute. Your mass slightly bends space-time around you. The effect is unimaginably small, drowned out by the planet beneath you, but it is real. In principle, sensitive enough instruments could detect it. Nothing is ever truly neutral. This realization collapses the idea of isolation. There is no object that exists without consequence. Every presence alters the environment, however subtly. Every moment adds a tiny deformation to the cosmic fabric. The universe is a conversation, not a collection, and gravity is the grammar that holds it together. On the largest scales, this grammar becomes almost poetic. Vast filaments of galaxies stretch across the cosmos, tracing invisible curves shaped by gravity over billions of years. Between them lie enormous voids, regions where matter is scarce, not because gravity failed, but because it succeeded elsewhere. Gravity gathers unevenly. It amplifies small differences. It rewards imbalance. A slight excess of matter grows into a cluster. A small emptiness becomes a void. Over time, the universe organizes itself into patterns that feel intentional, though no intention exists. Structure emerges because curvature compounds. This is why the universe looks the way it does. Not smooth, not uniform, but textured, webbed, and complex. Gravity does not seek order or chaos. It creates both, depending on perspective. From far enough away, the universe is almost homogeneous. From closer in, it is wildly uneven. Both views are correct. Gravity allows scale to matter. At human scales, Gravity feels constant and predictable. At planetary scales, it governs orbits and tides. At stellar scales, it ignites fusion and determines lifetimes. At galactic scales, it shapes spirals and halos. At cosmic scales, it decides the fate of expansion itself. The same principle repeated without modification. There is no separate gravity for stars, and for people, there is no stronger version reserved for galaxies. The rule does not change. Only the context does. This continuity is what makes gravity so difficult to escape conceptually. It is always present, always relevant, always shaping outcomes in ways that feel natural because they are unavoidable. You do not notice gravity most of the time because you have evolved inside it. Your intuition has been trained by curved space-time since birth. Falling feels obvious. Standing feels normal. Weight feels intrinsic. But none of these are properties of objects. They are properties of geometry. If space-time were different, your instincts would be wrong, and somewhere in the universe, around neutron stars and black holes, they are. There, gravity becomes so intense that familiar ideas fail. Time slows. Paths loop. Futures narrow. The geometry becomes so steep that escape itself requires moving faster than light, which nothing can do. These regions are not monsters. They are consequences. They show what gravity looks like when curvature is pushed to its extreme. Not a force gone wild, but geometry pushed beyond intuition. Black holes are not holes at all. They are places where space-time has folded so tightly that outward paths no longer exist. Once you cross that threshold, there is no direction that leads back, not because something blocks you, but because the concept of back has lost meaning. Gravity does not trap you. It redefines where you can go, and in doing so, it reveals its true nature. Gravity is not something acting on the universe. It is something the universe is doing to itself. A continuous adjustment, a constant negotiation, a silent shaping that never pauses. From the fall of a coin to the collapse of a star, the story is the same. Space-time curves. Objects follow. History unfolds. And it has been happening uninterrupted since the first moment time itself began. Yet even gravity has limits that feel almost philosophical. It can bend space-time, slow time, and redirect light, but it does not choose an ending. It sets conditions, not conclusions. The future remains open, shaped by balance rather than intent. This becomes clear when we look at the universe as a whole. For most of its existence, gravity has been trying to pull everything together. Every galaxy, every cloud of gas, every wandering particle feels that inward tendency. Left alone, gravity would eventually draw all matter back into dense knots, collapsing the universe into stillness. But the universe did not remain still. It expanded. Space itself began to stretch, carrying galaxies away from one another. At first, gravity slowed this expansion, resisting it quietly. Matter clumped, stars formed, structure blossomed. For billions of years, gravity appeared to be winning the argument. Then something unexpected happened. The expansion began to accelerate. Distant galaxies started moving away from us faster over time, not slower. The fabric of space was not just stretching. It was stretching faster and faster, as if driven by a pressure built into space-time itself. This discovery did not overturn gravity. It exposed its context. Gravity is powerful, but it is not alone. The geometry of space-time contains more than curvature from matter. It contains energy, even when space appears empty. This background influence, often called dark energy, does not pull objects together. It pushes space apart. not like an explosion, but like a steady tension, uniformly present everywhere. Gravity pulls. Dark energy stretches. Neither cancels the other. They coexist. And the fate of the universe depends on their balance. In regions where matter is dense, gravity still dominates. Galaxies remain bound. Clusters hold together. Stars continue their ancient dances. Locally, gravity feels eternal. But on the larger scales, the stretching wins. The universe is not flying apart through space. Space itself is expanding between things. This distinction matters. Nothing is moving through space-time faster than light in its own neighborhood. Instead, the distances between distant regions grow because the geometry between them grows. Gravity remains intact. It simply operates within an expanding framework. This is another reminder that gravity is not a global command. It is local. It shapes nearby motion with extraordinary precision, but it does not dictate the overall size of the universe. There is no center where gravity pulls everything inward, no edge where it fails. The expansion happens everywhere equally, while gravity works wherever matter gathers. The universe is not a tug of war. It is a layered process. Zoom in and gravity sculpts detail. Zoom out and expansion defines the backdrop. Both are true at once. This layered reality challenges intuition because we expect a single rule to dominate, but the universe does not favor simplicity. It favors consistency across scale, even if that consistency produces complexity. Gravity ensures coherence. Expansion ensures openness. Together, they prevent stagnation. Without expansion, gravity would eventually erase variety. Without gravity, expansion would leave only emptiness. The universe exists in the tension between the two, and that tension is dynamic. Over immense spans of time, galaxies beyond a certain distance will slip beyond visibility. Their light will never reach us, not because it stops shining, but because space between us grows too fast. Gravity cannot hold them, not at that scale. From the perspective of the far future, the universe will appear quieter, fewer galaxies, more darkness, not because things ended, but because connections faded. This is gravity's limit, not a failure, but a boundary. It governs relationships, not totality. It decides what stays bound and what drifts away. It draws lines not in space, but in influence. You belong to a small gravitational community. Your planet, your star, your galaxy. Beyond that, the universe becomes unreachable, not through distance alone, but through expanding geometry. Gravity defines your neighborhood, not your horizon. This realization reshapes what it means to be small. You are not insignificant because you are tiny. You are significant because you are connected. Your atoms are bound by gravity's long history. Your existence depends on structures gravity preserved long enough for complexity to emerge. The universe does not care about you personally, but it makes room for you structurally, and that is enough. Gravity does not promise meaning. It allows meaning to arise. In the quiet balance between pull and expansion, between curvature and stretch, the universe remains unfinished, not collapsing, not tearing apart completely, just evolving. And as long as gravity continues its patient work, shaping neighborhoods within an ever-growing cosmos, there will be places where matter gathers, time deepens, and stories can exist. Including this one, there is one more quiet consequence of gravity that rarely gets discussed. Gravity gives time a direction, not an arrow imposed from outside, but a tendency that emerges naturally wherever matter gathers. In regions shaped by gravity, processes become irreversible. Stars burn fuel, orbits settle, systems relax into stable patterns or collapse into denser states. Gravity encourages outcomes that cannot simply be undone. This is not because gravity prefers an ending, but because curvature allows energy to flow toward balance. And balance, once reached, limits what can happen next. A cloud of gas collapses into a star. A star exhausts its fuel and becomes a remnant. A remnant cools and fades. At each step, possibilities narrow. This narrowing is subtle, but it accumulates across scales. It is one reason the universe feels older with time. Not just because moments pass, but because options disappear. Gravity does not enforce this alone. Thermodynamics plays its role, but gravity amplifies it. By pulling matter together, it concentrates energy, accelerates processes, and deepens the sense of before and after. Time becomes textured. Near massive objects, this texture grows more pronounced. Clocks tick at different rates. Futures diverge depending on paths taken. The same event can appear stretched or compressed depending on where you stand. Gravity makes simultaneity fragile. Two observers in different gravitational environments cannot agree perfectly on what now means. Their experiences of time are equally valid, yet incompatible. This is not an illusion, it is structure. Time is not universal because space-time is not flat. Gravity bends both space and time together inseparably. When you move through gravity, you're also moving through time differently. You age at a rate shaped by the mass around you. On Earth, the difference is tiny, measurable only with atomic clocks. But it exists. GPS satellites must correct for it. Without accounting for gravity's effect on time, navigation would drift by kilometers each day. Gravity is embedded in practicality. It affects technology, not just theory. It influences every system that relies on precision, synchronization, or prediction. The more accurately we measure reality, the more gravity asserts itself. This leads to an unsettling realization. There is no single, universal timeline. The universe does not share one clock. It hosts countless local times, each shaped by gravity, motion, and history. What you experience as a smooth flow is a local agreement, not a cosmic standard. Gravity fractures time gently, without drama, into overlapping perspectives. And yet, coherence survives. Despite these differences, the universe remains navigable. Events still connect. Causes still lead to effects. Gravity bends time, but it does not break logic. It reshapes causality without destroying it. This is why gravity feels trustworthy, even when there is one more quiet consequence of gravity that rarely gets discussed. Gravity gives time a direction, not an arrow imposed from outside, but a tendency that emerges naturally wherever matter gathers. In regions shaped by gravity, processes become irreversible. Stars burn fuel, orbits settle, systems relax into stable patterns or collapse into denser states. Gravity encourages outcomes that cannot simply be undone. This is not because gravity prefers an ending, but because curvature allows energy to flow toward balance. And balance, once reached, limits what can happen next. A cloud of gas collapses into a star. A star exhausts its fuel and becomes a remnant. A remnant cools and fades. At each step, possibilities narrow. This narrowing is subtle, but it accumulates across scales. It is one reason the universe feels older with time, not just because moments pass, but because options disappear. Gravity does not enforce this alone. Thermodynamics plays its role, but gravity amplifies it. By pulling matter together, it concentrates energy, accelerates processes and deepens the sense of before and after, time becomes textured. Near massive objects, this texture grows more pronounced. Clocks tick at different rates. Futures diverge depending on paths taken. The same event can appear stretched or compressed depending on where you stand. Gravity makes simultaneity fragile. Two observers in different gravitational environments cannot agree perfectly on what now means. Their experiences of time are equally valid, yet incompatible. This is not an illusion, it is structure. Time is not universal because space-time is not flat. Gravity bends both space and time together inseparably. When you move through gravity, you're also moving through time differently. You age at a rate shaped by the mass around you. On Earth, the difference is tiny, measurable only with atomic clocks. But it exists. GPS satellites must correct for it. Without accounting for gravity's effect on time, navigation would drift by kilometers each day. Gravity is embedded in practicality. It affects technology, not just theory. It influences every system that relies on precision, synchronization, or prediction. The more accurately we measure reality, the more gravity asserts itself. This leads to an unsettling realization. There is no single universal timeline. The universe does not share one clock. It hosts countless local times, each shaped by gravity, motion, and history. What you experience as a smooth flow is a local agreement, not a cosmic standard. Gravity fractures time gently, without drama, into overlapping perspectives. And yet, coherence survives. Despite these differences, the universe remains navigable. Events still connect. Causes still lead to effects. Gravity bends time, but it does not break logic. It reshapes causality without destroying it. This is why gravity feels trustworthy. Even when it challenges intuition, it preserves consistency. It does not allow paradoxes to flourish. It constrains them away. Paths remain ordered, signals remain causal, stories remain tellable. Gravity allows complexity without chaos, and in doing so, it creates room for observers. Without gravity, there would be no stable structures to support memory, no persistent environments to allow learning, no long-lived systems in which awareness could arise. Consciousness depends on duration. Duration depends on structure. Structure depends on gravity. This does not mean gravity causes thought, but it enables the conditions under which thought becomes possible. It slows processes enough for patterns to persist. It holds matter together long enough for information to accumulate. You are not just standing in a gravitational field, you are thinking within one. Your sense of continuity, identity, and anticipation unfolds in a space-time shaped by mass and energy. Even reflection depends on gravity's quiet discipline, and yet gravity itself remains unaware. It does not know what it enables. It does not respond to meaning. It does not adjust for comfort. It simply curves space-time according to what exists. That indifference is what makes gravity reliable. It does not adapt to observers. Observers adapt to it. Over cosmic time, this reliability becomes legacy. Gravity leaves behind stars, planets, remnants, and trajectories that persist long after their creators are gone. Civilizations vanish, gravity remains. Languages fade, gravity continues shaping orbits. Memories dissolve, curvature endures. In this sense, gravity is the universe's longest memory. It carries forward the influence of everything that has ever existed, encoded not in symbols, but in geometry. Nothing leaves without leaving a trace. Even after matter disperses, the space-time it shaped remembers, however faintly. Gravity does not forget instantly. It relaxes slowly, reluctantly, asymptotically. The universe is never truly reset. Every moment builds on the last, not because someone keeps score, but because geometry accumulates history. This is the final quiet truth of gravity. It is not just what makes things fall. It is what ensures that the universe has a past. And as long as gravity continues to curve space-time, there will be a future shaped by everything that has already been.